So, building off of the previous example, we talked about one-to-one functions. If a function is not one-to-one, and we go to try to find the inverse, we'll be able to find an inverse. There is an inverse for that relationship because we're just switching the x's and the y's. However, if it's not one-to-one, when we take the inverse, that inverse is not going to be a function because we'll have more than one x for each y. Or for maybe one y, at least one y. So what we can do is we can do what's called restricting the domain, which means we're going to cut off part of the graph if it's not one-to-one, and we are going to keep only the part of the graph that would make it one-to-one. And then when we find the inverse, then it will be a function. So for example, if I look at this graph of x minus 5 squared. If I put that in on my calculator, that's going to look like this. This point right here would be 5, 0. It's a quadratic, so it has a smile shape, and instead of having the vertex or that minimum value at 0, 0, it's been pushed over to 5, 0. Okay, so as of right now, if I do the horizontal line test, it is going to fail the horizontal line test. So this is not a one-to-one function. However, if I cut off part of that graph, so I'm going to draw a line right through the middle. If I get rid of part of the graph, half of it, then when I do the horizontal line test, it will pass. So what I'm going to do, this question is saying is find a one-to-one function that is non-decreasing, which means we're looking for the part that's increasing. So I'm going to get rid of this part of the graph right here. I'm going to say I only want the right-hand part of the graph. I only want it when x is greater than or equal to 5. So I'm going to highlight that. I want this part of the graph right here. So I'm just going to ignore the left side. And this is what's called the restricted domain. So now, if I erase that part of the graph, and I try to do the horizontal line test now, it is going to pass. It's only going to go through one point on that function. So now it's one-to-one. Because we restricted the domain so that it did pass the horizontal line test. So now I know for f, the domain, if I look at this graph, the domain is everything from 5 to infinity. And the range for f is going to be from 0 to infinity. So this is the domain and range for f. Now let's go through and try to find the inverse. Let's do the inverse in blue. So I'm going to switch my x and my y. My f function is y is equal to x minus 5 squared. And I'm going to now switch the x and the y. So I have x is equal to y minus 5 squared. So I'm going to try to resolve this for y. So I'm going to square root both sides to get rid of that squared. And then I'm going to add 5 to both sides. Whoops. Okay, now, something I purposely didn't put in yet. Remember, when you square root both sides, you've got plus or minus. Okay, now, here's the thing though. I don't know which one to pick, but I can use my domain and range of f to figure out what my domain and range should be for the inverse. Remember, the domain are all the x's and the range are all the y's. And since we switch the x's and y's, the domain and range get switched as well. So when we look at our inverse function, my domain should now be the range of this up here, which should be from 0 to infinity. And my range for the inverse should be the domain. They get switched. So if I want my domain, all my x's, to be positive, then I want to use the positive square root, not the negative. So I'm going to use positive square root of x plus 5 is equal to y, which is my inverse. So here's the equation of my inverse, and then here's my domain and range of the inverse, because I switch my domain and range from my original function. Okay, the next example, it says find a domain on which the inverse function is 1-to-1 and non-increasing. So we want to look at the decreasing part of this. So if I look at the function x squared minus 3, that's just the function x squared bumped down 3. So I know for this function, the original function before we find the inverse, my domain is all real numbers, and my range is going to be -3 to positive infinity. However, we want to restrict the domain for the decreasing part. We want to keep the decreasing part. We want the non-increasing. So that means I want to get rid of this piece here. I want to restrict my domain so that my domain is from -infinity up to 0. So I'm going to fix that. So this is my restricted domain. Okay, so now when I go to find my inverse, this passes the 1-to-1 test, the horizontal line test. So I know that this is going to give me an inverse that is a function. And so when I go to find my inverse, let's do that one in blue. I know my domain is going to be the range from up here, because we switch our domain and range. And my range is going to be -infinity to 0. Okay, so to find the actual equation, I'm going to switch my x and my y. So I have x is equal to y squared minus 3. I'm going to add 3 to both sides. And then I'm going to square root both sides. So don't forget you've got plus or minus. And that gives me my y. Now, I want to make sure that my range and my domain matches the inverse of this. My inverse would look like this when I graph it, because remember, it should be a reflection across the line y equals x. And in order to make sure that it has that shape to it, it's got to be the negative square root. So my final answer for the inverse is going to be f inverse is negative square root of x plus 3. This is going to be my inverse. So to decide if you use your positive or minus, look at your restricted domain, look at your original function, and when you flip that across the line y equals x and you get that reflection, you just make sure that you pick the correct sign, whether it's plus or minus, to make sure that it matches up with your inverse.